We're given a function and asked to find an absolute minimum. The best way to find an absolute minimum is to have a sense of what the graph looks like. So my first order of business would be to graph this piecewise defined function. And in doing so, let's graph the first piece here. Before I graph the cosecant of 2x on that interval, let's remind ourselves in general that the cosecant graph has an infinite number of alternating up and down U-shaped branches, here being the first one. And in general, the cosecant of x has its first asymptote at pi. This is something that you would memorize or be able to deduce from other factors. But in this case, we have a 2x. That's going to cause a horizontal compression of this graph by a factor of 2. In other words, everything is going to push in towards the y-axis. Rather than to physically redraw my graph, I'm just going to rescale my axes and cut the asymptote of pi in half, thereby essentially compressing this graph horizontally by a factor of 2. Now it's worth noting that this local minimum occurs at pi over 4. And that's relevant because we're only being asked to graph this function from 0 to pi over 6 until a new function takes over. And where is pi over 6? Well, watch the x-axis. It's slightly to the left of pi over 4, of course. And what I've deduced, therefore, is that in graphing this piecewise defined function, I'm only keeping a small little piece of the cosecant of 2x. Next, I have to graph the second piece of this piecewise defined function. Now, I'm trying to find the absolute minimum here. So this is really going to depend on whether or not the y value of 2 is above the end of that first curved segment or below it. And that I don't know yet. In order to deduce that, it would help me to know the y-coordinate of that endpoint there. But that, of course, is just the value of the function when x is pi over 6. I can find that by plugging in pi over 6 to the cosecant of 2x function. I did the algebra. Hit pause if you want to analyze that further. But the important point here is that that question mark on the y-axis has a value of 2 over radical 3. I could rationalize the denominator like this if I wanted to. But the question still remains, is that where is 2 relative to that? Is 2 above that or is 2 below that? Well, if you were to work that out, even without a calculator, you would know that it's lower than 2. Look at the bottom right corner. 2 over radical 3 is 2 over 1 point something. And 2 over 1 point something is definitely less than 2. And if that y value is less than 2, then 2 must be above that point. And that's relevant to this problem because since we're being asked for the absolute minimum, and we now know that the rest of the graph is above that point, the end of the first curved segment, then we know that the endpoint of that curved segment is the absolute minimum. And we can say that the absolute minimum value, listing the y value only here, is 2 radical 3 over 3. And that completes our third problem.